Good day, my dear students. How are you? Do you miss having a class with your classmates? Or do you miss your lessons? The answer is here. We will bring to you the School on Air in Science 10. This episode will be streamed through radio, television, Facebook, and other online modes of learning. And I will be with you throughout this episode. Call me Teacher Shaidir. We are about to begin, so bring your module and find a comfortable place. Check your speakers if you can hear me clearly and ensure that your screens are unblemished. I encourage you to place a notebook, a ball pen, and a highlighter beside you so you do not miss any important information from the discussion later on. Also, prepare water and snacks so you do not need to stand from time to time. Is everyone ready? That's good! We will now get down to our business. Let's begin! Our country is blessed with so many land features such as mountains and volcanoes. These features can be sources of different minerals or can be used for agricultural purposes. For example, we have the majestic and world-renowned Mayon volcano. Because of its activity, it produces fertile slopes and plains which are used by the locals to grow their crops. Also, found in the northeastern coast of Luzon is the Sierra Madre mountain range, which is home to many endemic species of flora and fauna. Have you ever wondered why our country is endowed with this kind of geologic features? In your previous lesson, you are done with plate tectonics and its relationship to the distribution of earthquake epicenters, active volcanoes, and major mountain belts. Previously, we talked about plate tectonics. There are 7 relatively large plates and a number of smaller ones including the Philippine plate. Here are the 7 major tectonic plates. First, the Pacific plate. Second, the African plate. Third, the Antarctic plate. Fourth, the Eurasian plate. Fifth, Indo-Australian plate. Sixth, North American plate. And seventh, the South American plate. The names of the minor plates are Arabian plate, Indian plate, Caribbean plate, Cocos plate, Juan de Fuca plate, Nazca plate, Philippine Sea plate, and Scotia plate. The plates move very slowly but constantly, and this movement is called tectonics. Thus, the theory of moving lithospheric plates is called plate tectonics. These describe the events within the Earth that give rise to mountain ranges, volcanoes, earthquake belts, and other features of the Earth's surface. The places on Earth where most earthquakes originated or some mountains and volcanoes were formed mark the boundaries of each lithospheric plates. As mentioned earlier, each plate is slowly moving relative to each other, causing geologic events to happen along their boundaries. Today, we're going to study the different types of plate boundaries. Let's take a closer look at our planet Earth. What is plate boundary and how many types of plate boundaries are there? Plate boundaries are the lines at the edges of the different pieces of the lithosphere. Lithospheric plates are moving due to the convection current in the Earth's interior. Lithosphere is made up of crust and the upper part of the mantle. There are two types of crust. The continental crust, which is thicker but less dense, and the oceanic crust, which is thinner and denser. According to the plate tectonic theory, the Earth's lithosphere consists of crust and the upper mantle, which moves slowly but constantly over time. This movement causes the formation of plate boundaries, namely divergent, convergent, and transform fault boundary. Let's discuss them one at a time, starting with the first type of plate boundary, the divergent boundary. Divergent boundaries refer to plates that separate and move apart in opposite direction, forming a new lithosphere, the young seafloor. This either occurs at mid-ocean ridges or at rifted continental margins, known as reef valley. Can you identify adjacent plates depicting divergent boundary on the picture shown? Based on the picture shown, one of the examples where we can locate the divergent plate boundary is between the North American plate and the Eurasian plate. The arrow on the picture shows that the plates are moving in opposite directions. Divergent boundary is also known as constructive boundary because it leads to the formation of some geologic features such as mid-Atlantic oceanic ridge and the continental reef valleys. The spreading rate at these ridges may vary from 2 to 20 cm per year. Although a very slow process, divergence of plates ensures a continuous supply of new materials from the mantle. The Mid-Atlantic Ocean Ridge is an example of spreading center which causes the divergence of the South American plate and the African plate. Other examples of divergent plate boundary are Pacific Plate and Nazca Plate. The second type of plate boundary is the convergent plate boundary. Convergent plate boundary is formed when two plates move towards each other. Convergent plate boundary has three types: oceanic to continental convergence, oceanic to oceanic convergence, and continental to continental convergence. In oceanic continental convergence, the oceanic plate bends downward into the mantle through the process called subduction. Since the oceanic crust is denser compared to continental crust, therefore it subducts. During collision of two plates, one has a continental edge while the other has an oceanic edge. From the diagram, it is clear that this event gives rise to the formation of a volcanic arc near the edge of a continental leading plate. The reason for this is because the denser oceanic crust undergoes what we call subduction process, or the bending of the crust towards the mantle. Since the mantle is hotter than the crust, the tendency is the subducted crust melt, forming magma. Addition of volatile material, such as water, will cause the magma to become less dense, hence allowing it to rise and reach the crust once again and causing volcanic activities on the continental leading plate. Another subsequent effect of the continuous grinding of plates against each other is the occurrence of earthquakes. The subduction of plate can cause earthquakes at varying depths. Most parts of the world experience occasional shallow earthquakes, where the focus is within 60 km of the Earth's surface. In the convergence or collision of two oceanic crusts, island volcanic arc is formed parallel to the trench. The molten material will rise to the surface, creating a volcanic island arc parallel to the trench. As you can see in the picture, volcanic island arc is a chain of volcanoes positioned in an arc shape. Earthquake occurs at this boundary. Like the first type of convergent boundary discussed earlier, converging oceanic plates will cause the formation of trenches, also called submarine valleys. Ocean trenches are the deepest part of the ocean. One of the deepest is the Philippine Trench with a depth of 10,540 meters. These trenches will become sources of earthquakes. Underwater earthquakes, especially the stronger ones, can generate tsunamis. Tsunami is a Japanese term for harbor wave, which means a series of ocean waves with a very long wavelength caused by large-scale disturbances in the ocean. The Philippines is a country in Southeast Asia in the Western Pacific Ocean. It is an archipelago made up of 7,106 islands located in relation to many of Southeast Asia's main water bodies: the South China Sea, Philippine Sea, Sulu Sea, Celebes Sea, and Luzon Strait. Let's take a look at the formation of the Philippine archipelago. Many parts of the Philippines originated from oceanic to oceanic convergence. This resulted from the collision of two oceanic plates with one of the plates diving under the other. Most of the islands in the Philippine archipelago are considered as part of the Philippine Mobile Belt. These islands were formed 65 million years ago at the southern edge of the Philippine Sea Plate and are considered as part of island arcs. Other parts of the Philippines, such as Palawan, Mindoro, and the Zamboanga Peninsula, are all highland sections of the Sundaland Block of the Eurasian Plate. On the eastern side of the Philippines, trenches like the Philippine Trench and East Luzon Trough are both products of subducting Philippine Sea Plate beneath the archipelago. Aside from the formation of trenches and troughs, the downward movement of oceanic lithospheres underneath the Philippine archipelago creates active volcanic chains. For example, the descent of the West Philippine Sea oceanic lithosphere along the Manila Trench created a volcanic change from Taiwan to Mindoro. Some of the known active volcanoes in this chain are Pinatubo in central Luzon and Taal in Batangas. When two continental plates converge, a collision zone is formed. Unlike the other two types of convergent boundaries, subduction ceases for this particular type of boundary. No trench, no volcano, and definitely no island arc are created during this process. Both plates collide and buckle up, causing mountain ranges such as the Himalayas mountain range. Examples are boundaries between Eurasian plate and Philippine plate, Nazca plate and South American plate, and the Pacific plate and Australian plate. The third type of boundary is the transform fault boundary. Transform fault boundary is formed when two plates are sliding past each other. It is also called strike-slip fault. Rocks that line at the boundary split into pieces as the plates slip at each other. A crack is then formed, creating an undersea canyon or linear fault valley. Transform faults join two segments of mid-ocean ridge. Remember that the presence of a ridge is an indication of a diverging plate. And as the plates diverge between two segments of the mid-ocean ridge, the adjacent slabs of crust are grinding past each other. Although most transform faults are located within the ocean basins, there are a few that cut through the continental crust. The best example of transform fault boundary is the San Andreas Fault. The immediate concerns about transform fault boundaries are the earthquake activities triggered by the movement along the fault system. We are done discussing the different types of plate boundaries. But before I end this discussion, don't forget that plate boundaries are the lines at the edges of the different pieces of the lithosphere. Lithospheric plates are moving due to the convection current in the Earth's interior. Lithosphere is made up of crust and the upper part of the mantle. There are two types of crust: the continental crust, which is thicker but less dense, and the oceanic crust, which is thinner and denser. Again, there are three distinct types of plate boundaries which are differentiated according to the movement they exhibit. These are divergent, convergent, and transform fault boundary. Let's have further discussions on the processes and landforms that happen along plate boundaries next week. Congratulations, my dear students! You were able to reach the next level with your skills and understanding. To deepen your knowledge on this lesson, open your module and do the enrichment and assessment activities for you to work on to strengthen and master the basic concepts you have learned on this lesson. Be sure to answer all your activities and assessment. For more information and inquiries, you may ask your science teachers. In addition, drop boxes are provided near you. Always remember to abide by our community rules against coronavirus. Mahatma Gandhi once said, "It is health that is real wealth and not pieces of gold and silver." Once again, I am Teacher Shaidir. Sulong Edukalidad! Be sure to tune in Bamboo Telescuela. See you next week!